Hello students, let us discuss oxidation of alcohols. As we know that in alcohols OH bond is there. So we have learned that there are some reactions of alcohol which involve the cleavage of OH bond, and there are some reactions which involve the cleavage of CO bond. But during the oxidation of alcohol, there is a cleavage of this OH bond as well as the CH bond. Because of this cleavage, there will be a formation of double bond between the carbon and oxygen. That means there is a formation of a carbonyl group, that is C double bond O group. Thus, the oxidation of alcohols involves the formation of carbon-oxygen double bond, that is due to the cleavage of OH and CH bond in alcohol. Such cleavage and formation of bond occurs in oxidation reaction. These also known as dehydrogenation reaction. So let us discuss how the oxidation takes place. That means the reactions which we need to discuss in different alcohol. First, let us talk about the primary alcohol. Oxidation of a primary alcohol gives rise to aldehyde, and the further oxidation of aldehyde gives rise to carboxylic acid. That means oxidation of alcohol gives aldehyde with the same carbon number, and the oxidation of aldehyde gives acid with the same number. Now look at the equation, how you need to make the product here. It's an alcohol, so RCH2OH. Now in this, the CH2OH during the oxidation, it turns to aldehyde, that means CH2OH, that you need to change into CHO. You can see how easily you can frame the product during the oxidation. Alcohol is converted into aldehyde, so whatever the alkyl group, you have to write the same alkyl group in the same way, but in the place of CH2OH, what you need to write? You have to write CHO, that means alcoholic group. Now it is changed to aldehyde. As I told you, there is a cleavage of CH bond and OH bond that result in the formation of C double bond O, that is a carbonyl compound formed aldehyde. Now further oxidation give rise to acid. Now what you need to do here, CHO you have to change into COOH. So in simple words, how I can write this one, RCH2OH, that is an alcohol which is on oxidation. This part is converted into CHO, that is RCHO. Now which is further on oxidation, aldehyde group turns into acid, that is RCOOH. So you can make easily the reaction. You have to keep the R as it is. Just you need to change CH2OH into CHO, and the CHO you have to change into COOH. That is alcohol give rise to aldehyde, aldehyde give rise to acid. You can take one of the example by keeping the R as, when you keep R as a CH3, then this is called as a 2 carbon alcohol. That is how it is comes 2 carbon, R is CH3 and CH2, that means 1 plus 2, 2 carbon alcohol, that is ethanol. Ethanol give rise to water, CH3 CHO, that is acetaldehyde, which is called as ethanol, and that is giving rise to ethanoic acid, that is CH3COOH. So you can make easily the product by using this general equation. That is about the primary alcohol. And this primary alcohol is giving rise to an aldehyde, which is further on oxidation giving rise to acid. But there is some method by which alcohol can be directly converted into acid. For this, you need a strong oxidizing agent like KMNO4. So, strong oxidizing agent such as acidified potassium permanganate, that is KMNO4, are used for getting the carboxylic acid from the alcohol directly. As I told you, the oxidation of alcohol give rise to aldehyde, and the oxidation of aldehyde give rise to acid. But the alcohol we can directly convert it into acid, but for this you need a strong oxidizing agent. Under the normal oxidizing agent, first it converted into aldehyde, then it converted into acid. But under the strong oxidizing agent, it can be directly converted into carboxylic acid. So this is what we have learned for the case of primary alcohol. That is, primary alcohol is giving rise to aldehyde and oxidation. But the secondary alcohol, it gives rise to a ketone on oxidation. You can see secondary alcohol on oxidation in the presence of oxidizing agent, it giving rise to ketone. How you can make the product very easily? Look at the equation. Here, this part that is to be turned into CO. That means CHOH. In the place of that, you have to write CO. So that is giving rise to ketone. Look at here how the reaction is taking place. I told you there is a cleavage of a OH bond. So the H get removed from here, and there is a cleavage of CH bond here. So this H also get removed. And there is a formation of double bond between the two atoms of carbon, that is carbon and oxygen atom. So that is resulted in the formation of a ketone because of the formation of C double bond here. So you can make easily the ketone, just you need to change CHOH into C double bond O. Look at here, the 2 alkyl group is as it is. A tertiary alcohol is very difficult to be oxidized because they do not have hydrogen on the carbon bearing the OH group. That is, this carbon, it does not have hydrogen. This carbon, that is an alpha carbon, does not have hydrogen. So because of this reason, it is very difficult to be oxidized. But when under the treatment with a strong oxidizing agent and under the very strong conditions at elevated temperatures, the cleavage of CC bond takes place. That is, here the cleavage of CC bond takes place. They form a mixture of ketone and the carboxylic acid. Both the ketone and the acid have less number of carbon atom than the starting alcohol. When you check here, this ketone and this acid which is formed here, it have less number of carbon than the starting alcohol, that is a tertiary alcohol. Because in the tertiary alcohol, when you find it here, 3 alkyl group and 1 carbon here, it is there, that is an alpha carbon. But in the case of ketone, you can see only 2 alkyl carbon and 1 this carbon is present. So that means if it is 4 number of carbon here, when the alkyl group is CH3, here there is 4 number of carbon. Here where you can find out 3 number of carbon, because CH3 and this 3 number of carbon, and here it is 2 number of carbon. So that means here during the oxidation under the strong conditions and elevated temperature of tertiary alcohol, the product which is obtained, that is ketone and the acid, and this ketone and the acid having the less number of carbon than this tertiary alcohol, because there is a cleavage of CC bond here, and the cleavage of CC bond takes place only in a strong conditions. So that is oxidation under the strong condition, the cleavage of CC bond takes place. First, this cleavage takes place, so this R get removed, so we are getting this part. This part is giving rise to ketone, and further when it is under the strong condition, again this cleavage takes place, that is CC cleavage takes place. So this part is giving rise to the acid. So you can say that in each cases one R, that is the alkyl part, is get removed because of the CC cleavage. So what we can say that the tertiary alcohols under the strong conditions, under the strong oxidizing agent, that is acidic oxidizing agent, like potassium dichromate, acidic potassium dichromate, acidic KMnO4, that is potassium permanganate, it is giving rise to a mixture of ketone and acid. So when you compare the oxidation of primary, secondary and tertiary alcohol, it is clear that the oxidation is taking place under a oxidizing agent. But in the case of tertiary alcohol, oxidation is taking place under the strong condition because it involves the cleavage of CC bond. So in the case of oxidation of primary alcohol, aldehyde are the product which is further an oxidation give rise to carboxylic acid. But under the strong oxidizing agent, we can directly convert into carboxylic acid. But the secondary alcohol on oxidation giving rise to ketone. But the tertiary, as I told you, it gives a mixture of ketone and carboxylic acid which have less number of carbon than the tertiary alcohol. So this is all about the oxidation reaction. It is one of the important reaction in the case of complete the reaction. The questions usually arises in the complete the reaction and important for the conversion type of equation. So here the oxidation is taking place in the presence of oxidizing agent. Let us see what are the important oxidizing agents, like alkaline, aqueous or acidified KMnO4, that is potassium permanganate. It is an important oxidizing agent for the oxidation of alcohols. Next, acidified sodium dichromate, acidified potassium dichromate, nitric acid, chromic acid, pyridinium chlorochromate. In short, we are writing PCC. It is also one of the important oxidizing agent which is used for the oxidation of alcohol. Next, pyridinium dichromate, that is represented by PDC, and the chromic anhydride. The formula for chromic anhydride is, that is CrO3, chromic anhydride. So these are the important oxidizing agent which is used for the oxidation of alcohol, which give rise to aldehyde, which is further give rise to acid. So that is all about the oxidation reaction of alcohol. So the next reactions will be discussed in the further videos. Have a nice day.